Calculating an effect size for correlation is much easier than calculating the effect size for a t-test or an ANOVA. This is because the correlation coefficient itself is also a measure of effect size. In fact, an R value can be squared to create an effect size. The squared value of the correlational coefficient, or R squared, is called the coefficient of determination. It is the proportion of variance in the dependent variable, y, explained by variance in the independent variable, x. For example, if the coefficient of determination between apple consumption and doctor visits is 0.463, then 46.3% of the total variability in doctor visits is explained by how many apples a person eats. If the R squared between burnout and job satisfaction is 0.42, the write-up would say, the effect size for burnout indicated that a large portion of the variability in job satisfaction, 42%, was accounted for by the level of burnout that the counselor experienced. The inverse of the squared value of the correlation coefficient, or 1 minus R squared, is the coefficient of alienation. The coefficient of alienation is the proportion of variance in the dependent variable, y, that is unexplained by variance in the independent variable, or x. So if the coefficient of determination between apple consumption and doctor visits is a 0.463, then the coefficient of alienation is 0.537, or 1 minus 0.463. This means that 53.7% of the reasons why someone visits the doctor is due to other reasons: heart attack, routine checkup, having a baby. An example write-up for the job satisfaction example would be 58% of the variability in job satisfaction was explained by factors other than the level of burnout among counselors, such as low pay, excessive paperwork, and inadequate health insurance. So there it is. I told you it was easy. Simply square the correlation value. Now that you know that, we will put this into practice when we do the full correlation write-up.